Hey folks, Keep Hope Alive here. I have a table of sound absorption, acoustical type materials. We got foams, we got sound absorption, we got barriers, we have Deadener. I'm going to give a little quick primer on what we use for terminology and what each of these things do. I've heard a lot of conversations really over the past couple of years. There seems to be some confusion in what words we should use to describe which materials. So I'm going to start on the left side here with some sound absorption. It's kind of been discussed lately. It's called Ultra Touch. It is made by Bonded Logic, and it's essentially kind of a recycled denim product, right? So it's made from recycled blue jeans. It's eco-friendly. It's designed for commercial construction. So this is a replacement for fiberglass bat insulation. When we're talking about sound absorption, we want an open fibrous material. Polyfill is plastic strands. We've seen tests done by Vance Dickinson in the Loudspeaker Design Cookbook, and others have done plenty of tests to say that polyfill, while it does better than an empty cavity, it really doesn't provide excellent sound absorption. We look to fiberglass bat or Dacron or Acoustic stuff, something fibrous. This is an excellent replacement for that, available at all major home improvement stores. So I use this, I stuff this in every single possible cavity I can find in a car to eliminate those structural resonance. Any open cavity, especially made out of metal, is going to want to resonate. It's going to want to ring at frequencies related directly to the dimensions of that cavity. So I stuff this as dense as I can. You can see, you can kind of squish it up. It's a little dusty, so I still wear a respirator, but it's not itchy at all. You could sleep on it if you wanted to. A companion product to that is a radiant barrier. Now this is a foil scrim designed as a vapor barrier. Inside it's that same recycled denim product, but you can see that it's compressed and it's also fairly thin. I use this inside speaker boxes, inside vented speaker boxes. I just simply staple it foil side towards the wood, this side exposed, and I kind of basically eliminate some resonance inside that enclosure that harmonics may excite and may kind of muddy sound. You're not going to use either one of these in a door unless you wrap them in plastic. Plastic such as a plastic bag. I like to use 1 mil PVC sheeting. Sound absorption in a door is vital. No one seems to do it. Closed cell products don't apply it, don't provide it. This is the kind of stuff that you want. When I'm talking about sound absorption indoors though, you're typically going to see me refer to a ceiling tile. This is a 2 foot by 4 foot compressed fiberglass ceiling tile. You can layer this up to the desired thickness. You can wrap it in plastic. This is the kind of thing that we use for commercial acoustics when we talk about fiberglass sound absorbing panels. So that's sound absorption. Moving towards foams, we have a closed cell foam. This is actually a adhesive backed product. So this is sold by Ram Audio. It's called Ensolite. We use this for gasketing. It does not provide sound absorption regardless what anyone says. It'll provide some minimal, mostly useless sound absorption. So we don't use it for sound absorption, we use it for gasketing. We mostly use this, or I use this, for minimizing rattles. Put this on the back of your license plate, bam, doesn't make any more rattles or noise. I use this all over the car. It's fantastic anywhere I want to isolate 2 panels, even around door clips. I use that for that. We have some other foams, we'll get to that later. Next we have Deadener. When we're talking about Deadener, we're talking about a viscoelastic or elastomeric property kind of material, right? So I have a viscoelastic product, I stick it to metal, I roll it down. This foil scrim is really just designed to keep it from getting too terribly sticky. That's its primary process or purpose. It also provides some mass, so you get kind of a constrained mass layer, but its purpose and all Deadener is really just to minimize structural resonance. So it converts low-level vibration to heat. It dissipates energy. Energy is neither created nor destroyed. Same thing with this stuff. Sound energy hits it, it has to do some work and energy to make it through. That's why we get sound absorption performance. So this is Deadener. This is the kind of stuff you want to use. There's plenty of good products out there. It's not asphalt based. It doesn't smell. It's really easy to apply. You need some of it because you need to kill some structural resonance. But really what we're looking for also in automobiles is airborne resonance. That's why we use lots of sound absorption. Remember, if it's dry, if it's a dry cavity, you can use this stuff. Automotive manufacturers use sound absorption all over cars these days. It's a fine thing to do, but not indoors. If you're going to put it in a door, you got to wrap it in plastic. Next, we get to mass-loaded vinyls or barriers. That's what this kind of stuff is. It's heavy, it's rigid, it's not very flexible. This stuff is actually called DB3. It's sold by Home Depot. It's the most affordable mass-loaded vinyl type product. They say it's not exactly mass-loaded vinyl, but it behaves equally as well. You can buy some nicer stuff, but you know, really you're not going to realize the transmission loss because flanking paths dominate all installations. So we install this wherever we can, on the floor or over doors, but it's heavy, it's a pain to work with. You got to seal all your seams, overlap your seams. If it's not watertight, it's not sound tight. So you got to pretty much build this like you would a contiguous bathtub. So it's a bit of a pain, but it's certainly worth it. If you need to increase the isolation of road noise, that's what you're using this for. So structural resonance, the ringing in panels, airborne resonance are eliminated with this. Panel vibrations eliminated with this. Road noise eliminated with this. Next, we got some foams. We have the fast rings. So everyone's heard about fast rings. Essentially, it's a multi-ring product. You put it around your speaker, and it's designed to help seal the speaker to the door. Now, you can buy these. That's fine. I've been using the inexpensive $2, $3 analogy that I've been using this for well over 10 years now. This does the exact same thing, right? We're trying to seal the speaker to the door. It's vital. It's super important. I'm glad a company has come out with something that installers are finally using. You can use this if you want. You can also use this. That performs the same task. You should not have a gap this tall. This stuff does compress, but when you compress, it's going to want to fold in. It could put pressure on the surround. Be super careful when you use stuff like this that's this thick. And really, if you have this much of a gap, then maybe this is the thing you want to use, but ideally you'll build your baffle up and you'll get that to a more reasonable gap. You can get this in all kinds of thicknesses, multiple lengths, and it is super affordable. You also can use it for speaker gasketing. In fact, I think that might be what this project is sold as. So you can gasket speaker openings with it and create a nice airtight seal. You can also use Mastics. Mastics work as kind of an elastomeric or viscoelastic type non-hardening putty. They make them for electrical installations. You can get them for all sorts of purposes. Even coax seal does the same kind of thing. We have felts. From a felt standpoint, again, this is more for vibration or panel isolation. So if you got two panels vibrating, you could use something like this between them. The thicker stuff you could even wrap wire with if you want to have wire be fairly quiet. It'll be a bit tedious, but certainly vibration, panel isolation. You can also use stuff like this. This is a closed cell foam water resistant gasket. Sill seal is essentially designed for sealing anything from a commercial standpoint, but you can use a spray adhesive, spray that down on panels and get some vibration isolation in that as well. Now, one quick test we want to do with that speaker ring is we're going to see if it absorbs any water. I should actually do this as a separate video, but we'll do it here. So in order to put this in a door, and the manufacturer recommends that you put this center ring in a door to absorb sound, it should not absorb a lot of water. So we can see we get some pretty good results right away. It's not soaking in like you'd typically expect. If it was open cell, it would have absorbed automatically. So it does actually provide some pretty decent water resistance, but not totally. We are getting moisture that's soaking into this stuff. And while you're not going to pad it in your door, it's going to get wet. It is going to hold water. Our hope is that over time it doesn't harbor mold. But anything that holds water has an opportunity to also hold dust. You'll notice the inside of your doors are dirty. I don't use foams inside doors. Anytime I put foam or fiberglass or any sound absorption in a door, I wrap it in plastic. If I wrap something in plastic, I can pour water on it, and I think all of us know exactly what's going to happen here. Is it going to absorb into the plastic? No, it's not, because we all know that plastic doesn't do that. So now I have a nice dry surface. I have a surface I can protect all my sound absorption with. It's as simple as that. That's what I do. If you got any comments, feel free to let me know or ask me any questions. Have a great day.